Hi, we're back. We just talked about the difference between a change in a line or curve. Well, it actually shifts its position versus a change along a line or curve. It's sort of like driving along, say, the 210 freeway would be staying along the same line, or then shifting the 210 freeway 5 miles north or south, and that'd be a change in the line. We'll talk about this more in on the chapter on supply and demand, because this really matters for supply and demand. This is the difference between a change in what we call demand versus a change in quantity demanded. And I will definitely make a big point about this when we get to supply and demand. A few more things to talk about in the math review, and the first one is the fact that there are nonlinear functions. And nonlinear functions means that the way that x affects y changes. So if x is a different number, it can affect y in a different way. So sometimes when x increases, it has a greater effect on y. Sometimes when x increases, it has a smaller effect on y. These are where you get your nasty equations with x squares and things like that. We're not going to have any equations for that in this class. The only equations that we're ever going to look at will be non-linear equations. Take that back. There'll be linear equations. We're not going to have any non-linear equations, but we are going to have some non-linear graphs. And so we're not going to have equations for them, but we have to be able to understand what they're telling us. And there'll be two kinds of nonlinear graphs. That first one would be acceleration, and the next one would be deceleration. Acceleration means as x increases, the effect on y is greater. This means that y is increasing at an increasing rate. If it's linear, then y would increase or decrease at a constant rate. Here, y is increasing at an increasing rate. An example of this would be when you first get on the freeway. Let's say you have a light there on the on-ramp, and it turns from red to green, and then you put your foot on the accelerator, and it takes off. Well, every second, you travel a greater and greater distance. And so graphically, it will look like this. Let's see, acceleration. So here you're on the red light at the on-ramp, and then the light turns green. You put your foot on the gas, and the first second you're not traveling that far, a little bit, but the second second you're traveling a little greater distance because you're speeding up. The third second you're traveling even a greater distance, and so on. The fourth second you're getting more speed, you travel greater distance, and the last second, 5 to 6, you have the greatest increase. So that means your curve is a straight line. It is getting steeper. And this means that x is having a greater effect on y as you increase x. Now we'll find this when we get to chapters on production, that there's the situations when your production can actually accelerate, which is very good for business. And then once you hit your cruising speed, I don't know, maybe 90 miles an hour, then it becomes a straight line. And that's acceleration. The other kind of change is deceleration. And here x increases. As x increases, the effect on y is less. This means y is still going up, but at a decreasing rate. An example of this is when you're cruising at, say, 90 miles an hour. You see a CHP behind you. You take your foot off the gas because you want to be cool. You're not going to put your foot on the brake. That's a giveaway. And you put your foot on the gas and hope you slow down fast enough. You're still going forward, but you're going forward by a smaller and smaller distance. And that would be deceleration. And that would look like this. Deceleration. So, we'll raise it a bit. And so here you're still going way too fast. You see the cop behind you, you take your foot off your gas, and then your car starts to slow down. You're still going forward, but you're traveling, your distance you're traveling is getting less each additional second. So you go from the second to third second, you travel less distance, and so on, and so on, and so on. Hopefully the CHP passes you by, and then you can go back to your 90 miles per hour. Graphically, you can see the curve is still going up, but it's getting flatter. As it gets flatter, that means x is having less effect on y. And you can actually draw little tangent lines that I did not do for acceleration, but you can do it here. Tangent lines are lines that they just nick the curve, don't pass through it, but what they do is they give you a reference point for the slope. And you can see these lines are getting flatter, which means the slope is getting less. If you come to a stop like that, so you are pulled over on the side of the freeway, you now are not traveling any distance at all, it would just flatten out here and there would be no more slope. And this happens also in production. Production tends to accelerate at first, and then at some point it ends and we start to get deceleration, which is a very key concept in economics. So we won't use nonlinear curves. Actually, we'll have a nonlinear curve in the next chapter. But we'll get back to nonlinear curves a lot when we talk about production and cost. Oh, I don't think I showed you this. It's cut off. So here, again, if you're pulled over, it'll be a flat line, and that means you're not going anywhere. Okay, the last concept is very important. We'll use this a lot in this class. And that is a percent change. Now, there are different ways to get a percent change. This is going to be the one that's used the most common. We'll use this a little bit. When we get to the chapter on elasticity, we're going to have to modify this a bit. But just to give you an idea of what this is a simple base percentage change. And that means we're starting from a particular starting point, a base. And the equation is right here, a very useful equation. Of all the things that I've used in my life in mathematics, this is probably the one I've used the most. And here we have the simple equation. We take the amount 2, which is the second amount, represents the current value maybe. Amount 1 is the previous one. And so essentially we're going from amount 1 to amount 2. And then you take amount 2, subtract amount 1 from it. That tells you the difference. You divide always by the starting amount 1, because we want to see where we are now compared to where we were. And then you times by 100 to change the decimal to a percentage number. And so, for example, let's say we're looking at your income. Let's say your income, say in 2018 was, I'll just make up a number, say it was say $20,000. And then your income in 2019 was, say, $30,000. And then the question is, what is your percentage change in your income? Well, this is amount 2. That's the current one. That's a 2. And this is amount 1. That's where we came from. And so we take amount 2 up here. We take $30,000. We can leave out the dollar sign because you can see dollars over dollars are going to cancel out. And that's why the indicator at the end will be just a percent number or percent value. And here's your 20,000. That is the amount for 2018. Now we don't divide by 2019 income because that's not where we came from. We came from 2018, so we divide by 20,000 and times by 100. Move this up. Sorry about that. It's too low there. So again, this is amount 2 minus amount 1 divided by amount 1. And then 30,000 minus 20,000 is 10,000, right? Divide by 20,000 times 100. Well, that's 10,000 over 20,000. If you knock off all the zeros, it's simply 1 over 2, right? 1/2. So this would be 0.5. 0.5 is 1/2 times 100. That will add 2 decimals to it, move it over, and that'll make it 50%. You need the percentage sign. If it's not there on a test, it's going to be marked wrong because it's not 50, it's 50%. So that means your income from 2018, 2019 has gone up by 50%. If your income would have been 40,000 in your 2019, that'd be twice as much. That'd be 40 minus 20. So 40,000 minus 20 would be 20,000 over 20,000. And that'll give you 100%, which means it's doubled. So if it increases by 100%, that means the number has exactly doubled. And that, in that case, that would be a case if income in 2019 was, say, 40,000 instead of 30. And that's the math you need for this class.